Hello my dear students, hope you all are doing great and have started reading the lesson Alcohol, Phenols and Ethers. In the last two sessions of the chapter, we have learned the general formula of all the three. We have also talked about the classification of alcohols and phenols. Then we have talked about the nomenclature, that is naming of this compound. Whereas in the later session, we have learned about the methods of preparation of alcohol, phenols and ethers. Hope you all have started preparing that. Well, in today's session, we are going to learn about the physical properties of alcohol, phenols and ethers. And we are also going to start with the chemical reaction. In that, we are just going to start with the laboratory test of alcohol. So, let's get started. So, today we are going to talk about the physical properties of alcohol and phenols. In physical properties, we are going to talk about nature of intermolecular forces, their physical state, whether they are solid, liquid or gaseous. We are also going to talk about the boiling point and solubility of this compound. So, let's get started. First, we'll discuss about the intermolecular forces that are present in it. In the next slide, we are going to discuss about the intermolecular forces that are present in this. We all know alcohol contains a OH group in it. OH is hydroxyl group, right? So the polar OH groups are held together by intermolecular forces named as hydrogen bonding. You can see in the structure, right? This is a structure of two alcohol molecules. You have a negatively charged oxygen and a positively charged hydrogen. There's a bond between these two molecules. These both are alcohol molecules and there's an intermolecular hydrogen bond present in between these two. Same way, if you consider two phenol structures, you have an intermolecular hydrogen bonding in it. So, we can see that because of the presence of hydroxyl group in it, which is polar, you have a strong hydrogen bonding between two alcohol molecules. This is the first physical property. In the next slide, we are going to talk about the physical states of alcohol. If we consider the lower alcohols, that is, if we consider the lower alcohols, they are toxic liquids and they have a characteristic odor. Whereas phenols, they are also colorless, they are toxic, they have low melting point and have characteristic phenolic odor. That means alcohols, they are colorless as well as they are toxic. Same way, phenols too are colorless and they have a specific carboxylic or phenolic odor. So they have hydrogen bonding present in it and also they have a specific odor and they are toxic too. In the next slide, we'll discuss about the boiling points of these molecules. Now when we talk about the boiling points of alcohols, boiling point increases as the molar mass increases. I repeat, the boiling point of the compounds increases as the molecular mass increases. Okay, as we move from methane to ethane, methanol, ethanol, as the molecular mass increases, the boiling point of the compounds also would increase. So, the boiling point is proportional to the molecular masses of that compound. For instance, in the slide, we are going to see some of the structures and we are going to focus on some of the boiling points of the compound. For instance, now in this slide, here you have methyl alcohol, that is CH3OH. The boiling point of methyl alcohol is 65. Whereas if the molecular mass increases, that means a carbon is added over here. So, the boiling point will now increase. In the other case, that is isopropyl alcohol, again one of the carbon is added, so boiling point goes on increasing. So, we can conclude from this slide that when the molecular mass increases, the boiling point of the compound would increase. On the other hand, in this case, if you consider secondary butyl alcohol, you have a side chain over here. You have a branch in this structure. So what happens when branching increases, the boiling point would decrease. If you consider ethyl alcohol or else if you consider propyl alcohol, the boiling point is 97. But in case of secondary butyl alcohol, the boiling point is 99.5. So when the branching increases, the boiling point would decrease. Same is the case for tertiary butyl alcohol. Here you have 3 branchings. So boiling point obviously would decrease. So because of branching or because of side chains, the boiling point would decrease. So far we have discussed about the physical properties of alcohols and phenols. As I told you, they are liquid, and we have seen about the boiling point. As the molecular mass increases, the boiling point also would increase. Now in the next slide, we are going to talk about the solubility. In the first slide, I have already told you that there is hydrogen bonding present in alcohols because of the presence of hydroxyl group in it. So when we talk about the solubility of this compound, phenols and lower alcohols having up to 3 carbons show appreciable solubility in water. They are little soluble in water, as they have ability to form intermolecular hydrogen bonding with water. So they are less soluble in water. Lower alcohols and phenols, they are soluble in water. Why is this case? Why lower alcohols are soluble in water? Because you have a hydrophilic group in it. Hydrophilic means water-loving group, and hydrophobic is water-hating group. So when number of carbon increases, this R means you can have methane, ethane, methanol, ethanol, propanol, and so on. So as the number of carbon increases, the hydrophobic group increases, and so the lower members are more soluble in water. So we can conclude that because of intermolecular hydrogen bonding, they are soluble in water. So this is the structure of alcohol molecule, where you have a negative oxygen and a positive hydrogen. So negative and positive, here you have a hydrogen bond which is present in this structure. This is the structure of alcohol and water molecule. Same way in your textbook also they have shown this structure. You have an aromatic ring and a water molecule over here, a negative and a positive charge, and hence you have a hydrogen bonding between this hydrogen of OH group and water molecule. So negative and positive, in between these 2 molecules you have a hydrogen bonding. This figure shows you the intermolecular hydrogen bonding between alcohols and aromatic alcohols, that is phenol and water. So far we have seen the 4 physical properties, that is solubility, lower members are soluble in water. Then we have considered about the hydrogen bonding, and we have seen that alcohols, phenols, they are colorless and they are toxic also. Now we start with, in the next slide, we are going to talk about the physical properties of ethers. Now, ethers, they are highly volatile. They get evaporated in the air. So they are highly volatile and highly inflammable substances. When we consider the lower members of ethers, that is dimethyl ether and ethyl methyl ether, they are gaseous. Other ethers are also colorless and they have a pleasant odor. Okay, and when we talk about the boiling points of ether, it is just same as that of alcohols and phenols. Boiling point of ether show gradual increase with increase in molecular masses. So as the molecular mass increases, same as we had talked in case of alcohols and phenols, same is the case with ether. As the boiling, as the molecular mass increases, as the number of carbon goes on adding up, what happens is the boiling point would increase. So you can see the trend in the table given in your textbook also. In the next slide, we'll talk about polarity and solubility of ethers. Now in case of ethers, intermolecular hydrogen bonding that holds two molecules together strongly. It's not present in ether as it was in alcohol. However, the miscibility of ether in water is similar to alcohol of comparable molecular masses. Why is this? This is because ether can form hydrogen bonding with water through ethynyl oxygen. So because of the ethynyl oxygen, it can form hydrogen bonding with water, and hence it is sparingly soluble. Whereas when we talk about polarity, in this case, since we can look at the structure, that is the ether group, that is COC, this is a linear molecule we consider. But it's not linear, and the bond angle is 110 and not 180 degrees. So the bond dipole moment of the CO bond do not change, rather it cancels each other, and therefore ether, it possesses a net dipole moment. So ether, it consists of a net dipole moment, and its polarity is bit less. So we have seen in the physical properties of ether, the boiling point is same like what we have considered about alcohol. As the molar mass increases, the boiling point also would increase, and here we have considered that they have to have less intermolecular hydrogen bonding. Now we will be starting with the next point, that is the chemical properties of alcohols and phenols. Okay, in chemical properties of alcohols and phenols, first thing we are going to study in today's session only is laboratory test of alcohols and phenols. So the first test which alcohols and phenols give is the litmus test. We all know that litmus, what happens is when it is an acidic solution, blue litmus would turn red. So alcohol basically are neutral towards litmus, that there is no change in the litmus paper. Whereas when we talk of phenols, they turn blue litmus red. That means that phenols have some acidic character. Now in the next slide, we are going to talk about reactions with bases. Phenols, how they react with bases. For example, acidic strength of phenol is being very low. Phenol do not react with sodium bicarbonate, which is a weak base, but it do reacts with NaOH, which is a strong base. So phenols, they do not react with sodium bicarbonate, which is a weak base, and it doesn't give any reaction. On the other hand, when phenol is treated with a strong base like NaOH, it forms water-soluble sodium phenoxide. Okay, it forms a water-soluble sodium phenoxide and are precipitated on acidification with HCl. Hence, we can conclude that phenol is a weak base. I repeat, phenols, they react with sodium bicarbonate, which is a weak base, and do not give any reaction. Whereas, when it is treated with a strong base, it gives the reaction. Hence, phenol is a weak base. Now, in this next slide, we are going to talk about alcohols. Now, alcohols, they do not give reaction with sodium bicarbonate and NaOH. Whereas, when alcohols are treated with strong bases like alkali, sodium or potassium, they do react with the liberation of hydrogen gas. The liberation of hydrogen gas tells you the presence of OH group. So, alcohols, they react with stronger bases like sodium or potassium with the liberation of H2 gas, which tells you the presence of OH group. Now we will move on to the next slide, and this is the distinguishing test for phenol. For example, if you are being given any organic compound and you need to detect whether it is an alcohol or a phenol. So this is a specific test where you get a deep purple or violet coloration. Okay, in this case what happens is phenols, they react with nitrous ferric chloride. Phenols react with nitrous ferric chloride solution and gives you a deep violet coloration of ferric phenoxide. So this aromatic compound would react with your ferric chloride to give you a deep colored solution of ferric phenoxide, and HCl is given out. This is a distinguishing test where we can identify the given compound is phenol. Now we'll move on to the next test. Now this is known as the LUCAS reagent. What is LUCAS reagent is? It is a solution of concentrated HCl and anhydrous ZnCl2. This particular reagent is a very important reagent wherein we can conclude whether the given compound is primary, secondary or tertiary. That is, whether the given alcohol is primary, secondary and tertiary. How do we know whether it is a primary, secondary and tertiary alcohol? So in case if it is a tertiary alcohol, what will happen is the alcohol reacts fast and the reagent turns turbid instantly. So in case of tertiary alcohol, the turbidity is seen instantly. In case of secondary alcohol, the turbidity will be shown slowly. And in case of primary alcohol, we need to heat it and then we can see the turbidity. So this reagent, that is the LUCAS reagent, which is a mixture of concentrated HCl and anhydrous ZnCl2, will help you in distinguishing between whether the reagent given is a tertiary alcohol, secondary alcohol or a primary alcohol. So what happens in this reaction is your alcohol is treated with a mixture of HCl and ZnCl2, which is known as LUCAS reagent, and you'll get RCl and H2O would be given out. You'll get halogen as the product. So why LUCAS reagent is useful or important is because you can know whether the given alcohol is primary, secondary and tertiary on the way it turns turbid. Fine. Now in the next slide, the last slide, we are going to discuss about the uses of alcohol, phenols and ethers. In the introduction part, I've talked about this, few lines I've talked about this. So well, the things which are given in your textbook is alcohol, that is methyl alcohol, is used as a solvent for paints and varnishes. Ethyl alcohol is used as an anti-freezing agent in automobile radiators. It is also used as a solvent. So we can conclude that alcohols are good solvents. Whereas ethers, that is earlier diethyl ether was used as a general anesthetic in surgical operation, but nowadays it is replaced. Then it is also a good solvent when we prepare Grignard's reagent for fats, waxes, oils, etc. Whereas phenols are used as antiseptics in common products like air fresheners, deodorant, mouthwashes, floor cleaners, etc. So alcohol, phenols and ethers, they have ample of uses. They are a very good disinfectants. They have many bactericidal properties. So this is all about alcohol, phenols and ethers. So far we have learned about the physical properties of alcohol, phenols and ethers, and we have also started with chemical reactions of alcohol, phenols. In that we have just talked about the laboratory test. In the coming lectures, we are going to talk about the chemical reactions of alcohol, phenols as well as ethers. Please students, solve the questions which are given behind the textbook. Start practicing the named reaction and keep studying. Thank you.